Women in STEM by Yamini, Robert, and Paul. During the middle of the 20th century, nearly 80% of teenagers in America were enrolled in high school. The 20th century brought much success and funding to American public schools, and for citizens all over America, public education was seen as the fulfillment of the nation's democratic promise. The education system in the United States shifted after World War II and began to adapt to the process of filtering and guiding children into specialized fields before college. This shift affected both the job market and people's perceptions on jobs. Gendered stereotypes began to move into new domains of the public education system, such as high school and college, and even carried on into the workforce. These stereotypes, along with social factors and perceptions, carry on into today's world and have led women to be majorly underrepresented in STEM fields. Though Title IX was passed in 1972, which made it illegal for schools to discriminate on the basis of gender, women still needed to make sure the law was enforced and that women's rights were actively sought out in education. There was a growing worldview that girls and boys did not do the same kinds of activities, and innately, boys were strong and active while girls were sweet and passive. As girls got to high school, they were often steered away from high-level courses in science and math. In 1970, less than 1% of all medical and law degrees that were awarded went to women. Historically prevalent stereotypes also fed into inequalities in education. There have been questions in society surrounding how traditional gender stereotypes influence students' confidence and also their perceptions of their own abilities. An argument made by Steele and colleagues says that because of the perception that boys do better than girls on standardized testing, girls tend to experience more anxiety during test taking, especially during math, which interferes with their performance. This could further relate to why women aren't as likely to pursue STEM careers. STEM stands for Science, Technology, Engineering, and Math, and is a quickly growing field in the United States. Now, time for some statistics. Out of all STEM workers, 76% are male, whereas only 24% are female. Though women comprise 20% of engineering school graduates, only 11% of them have careers as engineers. Furthermore, women's participation in science and engineering at the undergraduate level significantly differs by specific field of study. While women receive over half of bachelor's degrees awarded in biological sciences, they receive far fewer degrees in other STEM fields. In 2010, about 17.9% of computer science degrees went to women, 19.3% of engineering degrees, 39% of physical sciences degrees, and 43.1% of mathematics degrees. So why is it that there's such a disparity between the representation of women and men in STEM? Over the years, the argument of biological differences have often come up as a reason. Many people argue that there are more men in STEM because they're more suited for those fields and they are more capable of performing well. They also argue that the biology of men allow them to better perform things like mathematical reasoning, which may be true, but isn't necessarily a large factor. However, evidence supports the opposite. Boys and girls perform equally as well on math and science, especially in the early stages of education. Also, studies like this one done by Spelk say that males and females have equal abilities for math and science. The biological argument about inherent differences in genders is not relevant to this issue. The claims aren't supported well, and even though genders might have biological differences, it doesn't mean that they are the deciding factors. Rather than biological differences, women end up being less interested or capable in STEM because their environments don't shape them in the same ways as men. STEM fields are already generalized as male fields, so women may have less extensive STEM education compared to men. Guiding forces such as teachers or even one's parents can unconsciously use these gender stereotypes and corral young women into futures which don't involve STEM. Men are usually trained more in STEM-related abilities like math and science because society thinks of STEM as male. So even if there's evidence that men do better in STEM, it's not because men are more naturally gifted, it's because they were raised to be more gifted in those areas. Basically, the argument that women are innately less capable than men in STEM is wrong because it fails to account for societal forces that stem from gender stereotypes.
So we can't really say that men are biologically more capable than women. There's no evidence to support that. So what would be a good explanation? Well, as women go through the stages of education, they are shaped by gender stereotypes that drive them away from STEM fields. These sexist stereotypes can come in many different forms. For example, direct negative comments can affect women, but more commonly, unspoken bias discriminates against women in STEM, like wage gaps or less opportunities. Starting in high school, these factors affect women by discouraging them from pursuing STEM options even before they enter the field. As a woman enters high school, she is under pressure to explore her future career options. This is when such fields like STEM seem appealing, but it's also when students may start to rely on stereotypes. In a study conducted by Banchevsky, Westphal, Park et al., a diverse variety of participants were more likely to consider women scientists with feminine appearances to not be scientists. Basically, they used the stereotype that women are less suited for STEM based on appearances only. Even though it isn't directly related to high school experiences, it provides good insight into the process of stereotyping. A female high school student is likely to experience judgments based on her gender, and these may steer her away from pursuing STEM as a future option. And even if high school students don't encounter such negative comments, the expectation that they will experience stereotypes is enough to push them away from STEM. There was a study conducted by Carolyn Schuster that explored the interest regarding STEM of female high school students. Around 17% had interest in computer science, while 76% had interest in psychology and education. These statistics also involve a concept they use called anticipated effect, which represents what people expect they would feel in certain scenarios. The results showed that female students were less likely to major in subjects in which they might expect to encounter negative stereotypes. Also, female students said that they were discouraged because of underrepresentation in certain STEM fields, which makes this woman in STEM problem feed into itself. Because of negative stereotypes, fewer women go into STEM careers, which means that there are less mentors and role models. Both this effect and anticipated effect ultimately result in potential students not committing to STEM because they see that STEM fields have more gender dichotomies, stereotypes, and less women representation. So let's say this hypothetical student forgoes these stereotypes and continues studying STEM in college. Based on statistics, she's less likely to succeed than men in the same field, or even women in different fields. Even though over half of college students are women, and more women than men under 25 earn bachelor's degrees, female participation and persistence in STEM is low.
In Joy Gaston Gale's journal article, Attracting and Retaining Women in STEM, Gales completes a 4-year study of college students. The goal was to see how goals in choice major changed, and what affected that change. The study followed 4-year students who decide on a STEM major early on in their college careers. They used details on how often students visited with faculty, and how often they worked with advisors. Using Gales and Ampal's study, it is clear that the negative effects of things like not talking to teachers outside of class, or having lower test scores in GPA had a larger effect on women than in men. Essentially, the social environment didn't help women as much as it should have, and something needs to be done about this. This climate or institution doesn't push the right way to help everyone succeed, and that's an issue that needs to be solved. The climate doesn't only apply to college either. Based on a study from Food and Sing in 2011, 25% of women left their engineering career after the age of 30, compared to only 10% of men.
Even after high school and college and their respective institutional forces, women who persist in STEM have even more challenges to overcome. Women and men earn around the same number of college degrees, but less than a quarter of PhDs in certain STEM fields like engineering and computer science go to women. According to a study by Glass, Sassler, Levitt, and Mitchell-Moore, women are also more likely to switch out of STEM or leave their jobs in favor of ones in different fields. The researchers also say that this trend almost entirely explains the difference in STEM retention of women versus other fields. This education stage is also when the representation of women gets smaller and smaller, so women who are still in STEM potentially encounter more isolation and negative stereotypes, which results in such low representation. But perhaps the most challenging part of the STEM field stems from post-education, when people are looking for jobs. The statistics already seem conclusive. In STEM, only 29% of tenured track jobs are held by women, and 19% of all professors are women. In the workforce, almost half of all workers are women, but only 24% of the STEM field. Why is this?